Hey there, everybody. Welcome to the all-inclusive webinar between Fortress Power and Northern Arizona Solar Electric Wind and Sun. That's a mouthful.
It's not Solar Electric. Dang. Alex.
Well, I saw Solar Electric on the invite, So let's say this: Northern Arizona Wind and Sun, in parentheses, Solar Electric. After.
No, it's not Solar Electric. We rebranded.
Okay. NAZ Incorporated. Thank you all for joining us here today. I am very, very thrilled and grateful to have the Northern Arizona team here today. We have a great webinar plan. We're going to get started here in maybe just the next minute or two, and we'll go through a little bit of our agenda. We have a lot to talk about today, and we'll do a Q&A at the end of the presentation. So if you have questions on your control tab from which you joined, you can ask questions to us, and then we'll do maybe 10-15 minutes of Q&A at the end of the presentation. We will be recording this webinar, and we will have these slides sent out to all of you after the fact, so you'll have this at a later date. This will be available on YouTube as well. So thank you again for joining. We'll get started here in just 1 minute. All right, let's get started. For the sake of time, like I said, we do have a lot to cover today. My name is Alex Lepore. I am the sales director here at Fortress Power. More to come on who we are and what exactly we do. But I'm very, very excited to introduce my two co-presenters here today. We have James Hall, who is the engineering and sales manager. And we also have Therese Umholtz, who is the wholesale manager, both of which work with Northern Arizona Wind and Sun. I've worked with these two fine people for many years now, and I can definitely attest to their knowledge and expertise in our industry, along with battery-based systems and solar electric systems. So guys, thank you for joining us here today. I'm very grateful to have you all, and we can go to that next slide then, and we'll do a quick introduction of who exactly I am and what we do at Fortress.
Thanks, Alex.
So Fortress Power is a energy solutions provider ranging in sizes in energy storage systems and inverter solutions that range from 5 kilowatt hours all the way up to 4 megawatt hours. And the key thing with a lot of our solutions is that we started as a battery company, manufacturing the highest quality batteries up to the automotive grade for these residential and commercial applications. We are headquartered right outside of Philadelphia, Pennsylvania. For any of my East Coast folks, it's a small town called Langhorne, Pennsylvania, with 3 other office locations, one of which is where I'm located here in Southern California, just outside of Los Angeles, another office location in Asia, and then our last office location in Puerto Rico. We were founded way back in 2016, so we are over 5 years old. We are backed by a private equity partner. And since our inception in 2016, we've done over 25,000 installations, not only here in the continental US, but also abroad in international markets. So we are definitely not new to this battery and energy solutions game. We have been there and done that. And our experience is tried and true with being a key lithium battery supplier for several government and utility entities in that time. Towards the end of the presentation, we're actually going to discuss some of these very cool case studies that we've all worked on in both of our experience. When I say both, I mean Northern Arizona and Fortress Power's experience. So we're going to go through some of that and discuss some of the installation tips and tricks, and just take a look at some of the projects that are out there. Next slide, please. Batteries are really cool, right? Batteries have evolved a lot in the last 5 years, and certainly in the last 10 years. And you can use batteries on many different applications, right? Batteries had started off with where you would just use it to back up your home load, right? Back up your facility. If you were a solar customer and you did not have a battery and the grid went out, your solar stopped producing. So batteries came to the awareness of solar customers because they wanted to keep their solar running when the power went out. Since then, battery and the technology has really expanded, right? And you can use batteries in many different kinds of applications. You can use it in a self-supply application, right? Where if you're in a certain state or an area and your utility company does not allow you to sell back to the grid, a battery can help you capture that excess power so that way you can use it for your home, right? Achieve that grid independence that we hear so frequently. You can use it in a time of use application, right? So if you're where I'm located in California or in areas of like Southern California, particularly, we have this thing called a time of use rate, right? It's where they're billing you very high during peak times, for example, like 5 to 8 p.m. or during that dinner hour. Having a battery, you can discharge that battery during those peak times, so that way you basically avoid those high rate charges. And these charges will be maybe double or even triple sometimes what you would normally pay, right? So for example, I pay 20 cents per kW during an off-peak time, which is in the morning, for example. During these on-peak times, which is the time of use, I may be paying 40, 50, or even 60 cents a kW. So a battery can be used in this fashion. You can also use it to move completely off the grid, right? If you're sick of the utility company, then you can completely use a battery solution to move off the grid and have your own grid independence, right? There are different design considerations that the folks at Northern Arizona and I will discuss about when moving off the grid, because it is a very, how do I say, detailed approach that you have to maneuver. There's a lot of considerations to be made, but that is something that you can do with batteries. And then last but not least, you can reduce your demand. And what a demand reduction application is, where you basically keep the usage of your home or facility beneath a certain threshold of usage, so that way you don't get bumped up into the next billing cycle. So what I want you guys to take away from this is batteries have come a long way. This is not your grandfather's battery. You can use batteries for all these different applications, and more are certainly going to be coming. Next slide.
Well, I'll add to that. The demand charge is actually super important here, especially if you get solar, because if for every kilowatt you use in Arizona, depending on the utility company, and if you have solar and interconnection agreement, you can be charged $16 per kilowatt that you use. So if you used a 10 kilowatt during the peak period of time, it will cost you $160 on your bill. You can use an energy storage system and essentially lithium batteries to offset that peak demand and net it to zero. So for example, in my home, specifically set up my system so that no matter what, my batteries are full. They're capable of offsetting my demand between our peak period, and we use absolutely zero energy during that peak period to not only offset this astronomical time of use rate, but net that demand charge to absolute zero. So that doesn't have any influence on our electric bill, right? So that's an important consideration. Time of use and demand can go hand in hand with one another. So, all right, transition.
Yeah, well said. And to add to that with one final point, more utility companies are taking these kinds of structures, right, where they're enacting a time of use rate structure and a demand rate structure as well. So as if I'm a homeowner watching this webinar, do some research, right? Do your research on what utility company you have, because a lot of the times you're going to learn something you didn't know about how you're getting billed, and then the solutions that may be able to support you. So just a final note. Fortress started doing batteries in 2016, and since then, our flagship product has been our Evault Max, right? It is one big, beautiful battery, I call it. Inside the battery, we're going to show some pictures of this thing kind of exploded with an internal view. You'll see it uses a tier 1 automotive grade prismatic LFP cell. We have a 10-year warranty with 8,000 cycles. Going to discuss a little bit more about what the heck a prismatic cell is and why that exactly matters later in the presentation. But for your knowledge, it's the highest quality cell that is out there, right? High quality is going to make sure that you get the longest lasting battery and the most bang for your buck for your investment. For my folks in California, this is one of the largest units, if not the largest unit, on the self-generation incentive program, the SCHIP incentive, at a whopping 17.7 kilowatt hours of AC power. And because of its large size, it's very easy to install, right? You wheel in one large battery. It comes on casters, otherwise known as wheels. You wheel it in and you can plug it and play with your particular 48-volt hybrid inverter, and you can actually parallel or let's say increase the capacity of many of these Evault Max units up to 20, which is 370 kilowatt hours. It does have closed loop communication compatibility, meaning that it communicates with the inverter, the hybrid inverter via state of charge rather than voltage, which is discuss about some of the benefits of that closed loop communication capability. It is UL listed to 9540 and 9540A. For those of you not familiar, UL Underwriting Laboratories essentially sets the standard for new technology, right? So the Evault Max is listed to these new listings, 95.4 being as an energized system listing for safety, and then 95.48 is a large-scale fire testing. So you can feel very comfortable knowing that this passed large-scale fire testing through some of the most rigorous testing laboratories in the world with our Evault Max. These are 48-volt batteries. You'll see on the front of the battery, it comes with this LCD display, which can help you read some particular values. Next slide, please. I think the next one after that. So if you look at the internals of the battery, you'll see the battery here on the left. It's very easy to service, right? It's front accessible with a front door that can come off if you need to get in there to do maintenance work on the BMS, replace fuses, so on and so forth. If you had an instance where you wanted to use the Evault Max, there is actually a way where you can actually pull out the battery packs. Would not recommend without direction from Fortress Power, please. But you can actually pull out those battery packs and then move those battery packs into hard to reach areas, right? If you're moving it down some stairs, up into an attic, so on and so forth. So it is a one large battery, but front accessible to the point where you can get into the nuts and bolts very easily, right? So you can do maybe updates to your battery management system because of firmware updates to that particular hybrid inverter, or if you just want to perform some maintenance and see what the heck is going on. All of this information, and one of the key safety features is our LCD display that you'll see on the front. Next screen, please. So on the LCD display, you're going to see a couple of different values. You're going to see the voltage of the battery, right? What is the voltage of the battery at that point in time? What is the state of charge? What is the current that is being delivered to the battery, along with the power that is being output from the battery? You'll have the amount of batteries that are parallel together down here in the bottom right. And then over here, it may be a little challenging to see. You can see that these little circles are different safety features for an alarm, right? So these alarms will come off in the event that there's, let's say, a high voltage sensor had gone off or a low temperature sensor had gone off internally in the battery. So this LCD display allows you to know right on the front of your battery, not only the key parameters of how your battery is acting or reacting, maybe to home loads or to maybe a discharge that you're doing in the afternoon, but it also gives you that detailed information on these different safety features. It helps you understand what the root of the problem is. So when you call Fortress Power, we can help you diagnose it, troubleshoot it, and get your system back up and operational. So very, very cool solution. Again, tried and true and tested. We have thousands of these deployed in the field very successfully. Again, as we've had this product released for over 3 years now, I think at this moment. Next slide, please. If you didn't need something quite as large as the Evault Max, no problem. We got you covered. Evault Max is 18.5 kilowatt hours. This is our 5.4 kilowatt hour unit, the eFlex. This is the little sibling to the Evault Max. It is a more modular and scalable solution than the Evault Max in those 5 kilowatt hour increments. A couple things you'll note right off the bat. First, it is UL listed just the same as the Evault Max with the UL 9540 and 9540A. Again, energized system testing and large scale fire test. It uses the same tier 1 automotive LFP cell with that robust relay-based battery management system. More to come on that later. It is an outdoor rated battery. The enclosure is a 1/4 inch thick aluminum, right, which is going to help with heat dissipation along the battery. It is IP65 rated, so it is outdoor rated, is classified as a sealed battery. And as the name implies, it's very flexible with how and where you can install it, You could have this as a, where's my hand? As a wall mountable solution where you hang it up on a wall. We have a racked solution that you can check out on fortresspower.com, and you can install this into a rack and have multiple racks, or you can just have it as a standard floor standing battery. So very flexible for your installation. Again, it's a more modular solution, and you can parallel up to 30 of these together for 162 kilowatt hours. You could do this for a home energy storage system. You could use this for mobile applications, railway applications, marine applications, and telecommunication applications. It's very flexible, outdoor rated, very robust and sturdy battery, again, with a 1/4-inch thick aluminum with this ribbing that acts as a heat sink for dissipating that heat evenly across the battery cabinet. What that basically ensures is that the battery is going to get the maximum life even if it is installed outside. Be careful when you choose a battery. You want to make sure that they're not only outdoor rated, but they're using the right enclosure material. We're going to talk about why enclosure material is important later in this slide deck. So I'll keep you guys anxiously waiting for that synopsis in the next couple of slides. Next slide, please.
Oops.
What brings this whole thing together is going to be our Guardian, right? Our Guardian is going to be our remote monitoring platform for the eVault Max and the eFlex line. Compatible with iOS or Android, it's going to automatically connect to your Fortress batteries for product registration, aka warranty registration, monitoring each individual battery on site. Let's say if you had 15 of the eVault Maxes, you would still only need one Guardian that's going to monitor all of your batteries there. You can do remote firmware updates and maintenance through the Guardian platform, along with getting technical support. So James, if you could go to the next slide, you'll see a little demo on how the app actually looks, right? And you can see you'll have the primary residence on the far left that shows the power flows, let's say from the utility to the home or from the solar to the battery. And then you have these different applications, right? You have the middle, which is prioritizing your objectives for this solution on the grid, right? Is it a self-consumption objective? Is it a backup objective? Or are you just looking for the lowest cost of energy? Or if you're looking to move off the grid, you have an off-grid objective, right? Where you can look at backing up certain critical loads, or maybe different functions of off-grid comfort versus off-grid sustainable, right? And that's speaking to how you use the power when you're moving off the grid, right? If you live off the grid, the battery is one of the only things that can store and deliver power when you need, unless you have some sort of generator, which I would recommend if you move off the grid to have a generator for redundancy. So our Guardian is just a very snazzy application that connects with our batteries to give you monitoring data, technical support, warranty registration, and it brings your system whole and it brings it together. Something which, again, you just buy it once, you only need one, no matter how many batteries you have, and then you're off to the races. Next slide, please. Fortress Power had recently released its own new inverter, right? Partly because I mentioned UL 9540, if you guys remember. The second edition, believe it or not, of 9540 is requiring that battery systems or energized systems are treated as a package, right? So 9540 edition 2 is speaking to this fact that energized systems need to be packaged together to get this classification. So Fortress Power has a lot of other inverter partners that as you'll see, we value them and the solutions that they bring to the table. But with this advent of 9540A edition 2 coming, we released our newest NB12KW. It is a multi-mode string inverter and all-in-one solution, scalable up to 10 units for 120 kW, outdoor rated with a 200 amps of AC pass-through. So you can certainly move closer to what we'll call whole home backup. But again, remember, with whole home backup, what is the timing of that whole home backup, right? There is instantaneous power and then there's continuous power, right? This 200 amps of AC pass-through, that's great, but make sure that you read the spec sheet to know how much time that's going to deliver that 200 amps for you. It comes with the built-in rapid shutdown transmitter. For those that don't know, you need rapid shutdown for your solar system to fulfill the NEC code. I think it's 2017. And then there's 3 MPPTs. An MPPT is a maximum power point tracker. So for my solar designers that have joined this call today, you have a lot of flexibility. When you're designing your solar systems on your roof, you can have different strings depending on your site layout. Or if you're someone who's calling in looking for solar, what that means is you can design a solar system that's customizable to your home and to your needs. Now, I'd like to hand it off to the Northern Arizona team as they have some introductions on who they are and some of the services they provide. Thank you.
Hi, everyone. Thanks for being here. I'm Heather Smith with NAZ Solar Electric. We're super excited to be able to partner with our manufacturers and bring you in-depth information about a variety of products. So thank you for being here today. Who are we? We are an over 40-year-old company based out of Flagstaff, Arizona. We work with residential customers, commercial customers, as well as wholesale customers. So we've been around for a really long time. It's family-owned business, and we have a great team of people that are behind the scenes making sure that you get everything you need for your solar setup. We have a team of sales and engineering professionals who can help you design, who can help you commission, who support you for the life of your project. So from the very first time you think, I might want to get involved in getting solar put on my house, from that very first thought all the way 20 years down the road when you need to maybe update your system, we are there for you for the life of your system. Our team is always available to support once you install or once you have someone installed to make sure it's commissioned properly. And our goal is to make sure that solar is a snap. We support both the experts and the DIYers.
Thank you, Heather. And yes, yep. I mean, any project we will work with, large commercial projects, 1 minute, $500,000 project, all the way down to super small standalone project where, we're helping someone with a sensor and a small solar panel and a battery. Any project in between is really our forte. And, we really, really like the eVault Max battery for some of these larger off-grid and grid ESS systems, all right? And why do we really like this battery for that? I'm going to segue into this. I mean, first of all, there's not a whole lot of batteries in the industry that in one package can do 9 kilowatts of continuous load, okay? This battery, at a C/2 rate can continuously offer 9 kilowatts and peak at 12 kilowatts. So if you're tying this in with, for example, like a Sol-Ark 15K, you can really just use one battery to feed the max power to that inverter in a grid down scenario or in a completely off-grid scenario. But you can also scale this. I'll go into more detail here in a little while on the versatility of scale. But not only that, I mean, this battery has contactor-based BMS, which is really important for larger projects with bigger, more powerful inverters, okay? Your convention in this industry when it comes to lithium batteries is either going to be a FET-based BMS or a contactor-based BMS. We're going to go into a little bit more detail about this, but generally it's super important to have, for larger systems, to have this contactor-based BMS. It's a really important design consideration. Plus, internally, this battery has breakers for disconnect and overcurrent protection, as well as redundant fusing. So, I mean, both are serviceable and replaceable, but the breaker's there to easily allow for disconnect. And probably the most important aspect is the ability to do advanced closed loop communications to a number of inverters on the market. So that is very important when we design a system with lithium batteries, especially from the very beginning. It's a brand new solution. It's a brand new project. It is super important for us to have a relationship between the batteries and the inverter system. They need to be able to communicate. You need to be able to provide current, voltage, state of charge to the inverter and regulate that charge accurately and quickly. And that is what the eVault Max does. So big battery with nice, beautiful communications to certain inverter systems. That's what you want, all right? Alex talked about prismatic cells here.
Yeah, and I want to add, Northern Arizona has, an esteemed reputation, and for those of you that goodness gracious, for those that don't believe us, go to Northern Arizona's Google page, check out their reviews. I think that speaks for itself, the level of care and detail that goes into these projects. I've seen it firsthand, so I want to give you guys 2 thumbs up on that, just to give you guys some honest feedback. But thanks. As it relates to maybe a little bit on a different level, we're talking about battery cells. Very fun, right? So battery cells, not all lithium batteries are created equal. That's what I'll start with, right? Battery companies will use different kinds of not only different levels of the quality, tier 1, tier 2, or tier 3, a little bit more technical, but they'll also use different kinds of cells, right? And so on the left, you mentioned, or I mentioned earlier, prismatic cells. Prismatic cells are rectangular shaped, they're very large, but they're a lot higher quality. They're more durable, they're very much so more power dense than what we'll call like a pouch cell or cylindrical cell. These are all LFP, right? It's all lithium iron phosphate, but it's a way that it's capturing that LFP and then making that power. You can actually monitor with a prismatic cell with like the Guardian, you can actually monitor each prismatic cell in something like the Evault Max. The Evault Max has 16 prismatic cells located. They're large rectangular shapes, which allows you to do monitoring on each one of those cells. And again, with larger cells, you get more efficiency, more durability, because I want to be able to say, hey, this thing is going to last 10, 15, or even 20 years in some instances. Cylindrical cells had been very popular for many years, right? Just as you see on the right. I wouldn't say the problem with cylindrical cells, but the fact about cylindrical cells is that they're not, first there's going to be a lot of them, right? Versus 16 prismatic cells, you're going to have hundreds of cylindrical cells all soldered together, right? If one cylindrical cell goes down, you have no idea, right? You have no idea if that cell gone down and which cell it is, how to fix it, so on and so forth. So you have this thing of, so you have many different smaller cells making one battery. They are not as durable as a prismatic cell because of their size and shape, and they're just not as thermally stable as a prismatic cell, and because of that, what I'll call form factor. So as you guys consider batteries in general, Fortress aside, and look at what kind of cells that they have, right? If you want to go for a cheaper battery route, that's totally fine, but you are going to get what you pay for, right? If you pay for a cylindrical based battery, we'll call a cylindrical cell based battery, expect those returns based on things like life cycles or energy throughput. So again, we use prismatic cells. They're large, still lithium iron phosphate, which is that safest chemistry out there. But again, it's just a different way that we're capturing that power to be delivered to your home load. Anything to add, James, on that?
No, not really. I mean, conventional, there is certainly a market, within the market, a difference between the battery manufacturing, so prismatic cell versus cylindrical cells. But for the most part, we see a lot of manufacturers are now transitioning over that prismatic standard. Yeah. I think ideally because of the density, right? You get that high amount of capacity in one cell. You can keep your battery modularity essentially down to that 16 cell form rather than having like 150 cells or, like whatever it ends up being. Like, with the prismatic concept, you can focus on one battery either with 100 amp hour or 200 amp hour or 360 amp hour cells, and then series them to get your 51.2 nominal volt battery. So yeah, I think it's a more robust design principle is an important takeaway.
Yeah, really well said. And James, as you know, we started off Fortress with our legacy models like the LFP5 and LFP10. They used a cylindrical cell. Way back in 2016, we used a cylindrical cell when our company was started. So again, we had seen over the years that this fact that the cylindrical cell the prismatic cell was the direction we wanted to go because of all these things we had mentioned. So yeah, again,
certainly we're an early adopter of that convention. So
yep, that's right. And so I think what we're trying to get at is that a battery is a battery, but there's many things that make up a battery that makes a good battery good. Cell type is one of them. The second thing is going to be the enclosure, right? What is the actual enclosure material? See on the left, Fortress Power uses an aluminum enclosure, right? Aluminum is much more resistant to corrosion and salt and rust versus, let's say, what a plastic or iron case, especially with batteries being pushed outside, you want something that's able to be resistant to the elements. Iron and plastic over 10 years outside, especially in a coastal community or in a mountainous community, it's going to be tough. It's going to be really tough. There's going to be more maintenance on the enclosure. That's why sometimes you'll see corrosion on top of those old lead acid systems that are in those outdoor dwellings. That's why we chose that aluminum enclosure. I am partial to this. I think it looks great. You know, I think that aluminum sleek is a nice, very sleek finish, looks very modern. I am biased, obviously, but nonetheless, I think it looks a little bit cleaner, like futuristic technology, if you will. And then the last thing is I talked about heat dissipation, right? Heat dissipation is super important. Batteries are getting pushed outside, believe it or not, because of new things like NFPA 855, which is a building and fire code. You have the new NEC code, right, which is pushing batteries outside. So aluminum helps with this outdoor environment, but it also is going to help with managing heat and dissipating heat, so that way we can get the maximum bang for our buck as this battery is getting installed, right? It's easy to get a battery, but it's hard to find a very good battery that's going to last and act as it should, right? So aluminum enclosure is the direction we went. Certainly there is a place where you could do plastic and iron enclosures if you have an area which is protected from the elements, right? Because it is going to be an indoor installation only. That is certainly a possibility, right? A lot of these different kinds of batteries on the right, it is a little bit more of a time-consuming install because you have to parallel multiple batteries together. There's more design considerations because of the climate or climates of which you're installing this. So again, we talked about the cell, we talked about in the enclosure. Those are two main things that are going to extend your battery life, again, to maximize your battery investment.
I'll add to that. I think it's highly unlikely you're going to see a plastic battery with a UL 9540A listing.
Yep.
The takeaway there is that is kind of an important consideration, even if it's not a requirement for your particular installation. Think about that listing. This is a listing where they subject the battery to a thermal runaway situation. They literally heat up cells and cause a fire inside the battery on purpose. This is the UL testing laboratory, and then see how that fire propagates. And it has to propagate to pass. If it propagates inside the battery with a plastic case, it's not gonna stop, most likely, right? And so having the ability to dissipate heat, having the ability to contain is kind of an important characteristic in that test, right? So yeah, the listing aspects of things, it's kind of an underrated situation, but as an engineer in the industry, I look at those listings as a very important case situation for my recommendations. Like if you don't have a listing, you're not on par with what's required within the industry. And if you're not on par, then you're pretty much useless. So
that's a really good point. I think when we talked about like these enclosure casings, batteries are getting pushed outside, but it's another thing where, again, buying the cheapest battery, do your research beforehand. You know, that you could start with one solution and move on to the next solution. I like the Fortress solution it's high quality. You know, it's going to be very high quality. We're gonna make sure that we count our eggs before they hatch to make sure that, again, you don't have to work on some crazy runaround or anything. The third thing that makes the battery super important is the battery management system, right? This is essentially the brains of the battery. Probably, James, you can feel welcome to disagree with me, but I believe that it's the most important part of a battery is this battery management system, right? What are your thoughts?
I'm not going to disagree. No, it certainly is the most important part. I mean, to be honest with you, like there's a number of battery cell manufacturers out there that make a relatively similar standard cell. Like, cells, I mean, you obviously want to get a high quality cell because the quality assurance associated with that is, going to be held to a certain standard. So getting a quality cell is important. But for the most part, you're going to get, it's still the same chemistry, right? So you're still going to get the same life out of the cell, similar life out of the cells. The problem is with quality assurance, you might have situations where a cell has a failure and that's going to take out a battery. But certainly if you don't have a good BMS and it fails, it's going to destroy everything. So absolutely, the battery management system is by far one of the most important aspects of the system. And on top of that, the programming associated with that battery management system, the contingencies, the conservative aspects of that BMS are super important, and the ability to, be able to do firmware updates and closed loop communications, and all of that kind of rolls together as a very important consideration.
Yeah, Definitely. And so the one on the right is what the traditional battery management system was, everybody. And it's called a MOSFET. You heard it earlier, James said a FET. What he was referring to, it's a MOSFET. And a MOSFET is basically a little bit of a lower costing solution versus a digital processor. We'll get there in a sec. The problem with the MOSFET is just this single piece of like a circuit board. And with that, you don't have that same input and output power because of that limitation. With that, you have this, and I'm going to say this, nobody lose their head. You have this potential for thermal runaway, right? Where not good, right? You want to have a very good BMS that protects the battery cells and can handle high input and output power and respond quickly to an inverter's inrush current, right? Inverters are getting larger and larger. Shoot, look at the Sol-Ark 15, look at the Envy, look at Outback solution. These inverters are getting larger because the typical solar system is getting larger because the prices are coming down. You want a BMS or battery management system like the one on the left. It's a digital processor-based BMS with a solid state relay and fuse. What that means is that there's a fuse that will open the contactor. There is no way that power, if that contactor opens, is going to get from, let's say, the energized source or energy source to the battery. So it is a very safe, robust battery management system that's going to open up that contactor and say, no more power, I'm protecting my prismatic cells. I did mention it has higher input and output power versus a MOSFET and a quicker response time to an inverter's inrush current. So whether it's responding to inrush current and adjusting itself to handle that, or maybe it's just opening the fuse, right? Proper sizing and designing, I don't know if we may have this as a touch on topic here. Proper sizing and designing is paramount for batteries, right? If you do not properly size and design your battery management system is a computer. It's going to go, hey, what's going on here? You got way too much power coming into me. I need to open up my contactor because my main job is to protect the battery. So we talked about the actual cell level. I'm trying to find something don't have anything near me, but you have the cell level, you have the enclosure, and then you have the actual computer battery management system that is, again, the brains of the battery, the most important part. You don't want to skimp out on that. You definitely don't.
No, and the BMS is the advantage that the Fortress BMS offers is it's, for the most part, a fail-safe situation, right. Whereas a MOSFET-based BMS has the ability in certain situations to fail unsafe, which can be a massive design consideration when it comes to batteries. And if you don't know what you're doing, and you're using, cheap batteries that might have a FET-based BMS, and you don't take into consideration the fail-safe scenarios, you certainly will get into situations that are unfavorable. Anyways, I'll talk a little bit detail here on the battery. Fortress was nice enough to let our team, well, you can't give our team anything and not expect them to pull it apart. And so we didn't really give them the option to not allow us to do this. But here's the thing, this is a takeaway to the inside of the eVault Max battery, and it's not just, this is like legit behind my desk here for a while. So the takeaway here is, obviously we talk about the cells. They make the Fortress uses cells from a quality, reputable, well-known cell manufacturer. There's probably about, I don't know, 5 major manufacturers. If you ever go to like any of the solar shows, they often will be displayed, out there, and certainly Fortress uses one of the most reputable cell manufacturers. I'm not going to name them, but nonetheless. But here's the other aspects that are kind of important. And these are small considerations, but very important design principles, right? So this battery has a BMS controlled contactor system, right? So you can see the contactors there. It has a pre-charge contactor, it has a charge contactor, it has a discharge contactor, right? These are for different use case scenarios. For example, if your battery gets too discharged, the charge contactor can close and allow you to charge the battery without it being able to discharge. If when you start the battery up, it'll go through a pre-charge resistor. There's actually a pre-charge resistor there on the right-hand side. If you look, that's a big pre-charge resistor that allows you to charge the caps in the inverter whenever it's starting the connection up, which is a very important takeaway here. Like if you have a FET-based BMS that doesn't have pre-charge resistor, you can subject that BMS to maybe 4 or 5 or maybe even 10 times what it's capable of handling, and a pre-charge resistor will keep that current flow minimal so that it can charge the caps and then close the contacts and provide power to the system. That's very important. At the very bottom, you can see that it's fused, okay? This is a big 400 amp replaceable fuse. In the event you like dead short this battery and the BMS can't for some reason react fast enough, like you make a mistake. People make mistakes, right? The fuse can blow, right? And protect, because this battery can deliver ridiculous amounts of current, like mind-blowing amounts of current. Obviously, because it's rated at 9 kilowatts and 12 kilowatts, that's to prolong the life of the battery. That's not what it's limited to. I mean, certainly if you hook to these cells and you try to do something stupid, it'll do it. But that fuse helps to protect it. And then at the very top, which is hard to see, there's a breaker in there as well. And that breaker allows, obviously, you know, an overcurrent protection. It's essentially a disconnect and overcurrent protection for the battery. Anyways, these components are all serviceable, and should you ever have any issues, you can get in there and you can deal with them. Like, there's not a whole lot of batteries and manufacturers that offer these parts. You know, some of the batteries that we've seen maybe in a couple other slides, it's impossible to service them. The manufacturer will not let you do that, or they're completely sealed and you can't open them without cutting them. Like, these kinds of concepts it's a narrow-minded situation, because this battery in theory should be able to last you 15 plus years, and we'll talk about that in a minute. You know, but you know, it is possible for certain aspects of the component, especially if they're being used too much. For example, if you're like overcharging the battery, I mean, the BMS is going to protect itself. The contactor is going to engage and disengage. That's not the ideal situation. If you wear the contactor out, you can replace it. If the BMS, I don't know, God forsake, if you break a BMS because you're doing a firmware update incorrectly and you use the wrong firmware, you can replace it. It's replaceable, and that's super important from an engineering perspective, you know, and with respect to these batteries, right? All right, you talk about the cycle life, Alex.
Oh, cycles are fun. I love cycles. Man, where do I even start? So, a cycle. What the heck is
That's what we talk about. Throughput.
Throughput's another
I don't
good
care
one.
about cycles. Everyone seems to wrap their head around cycles, but let's just really focus on throughput, because that's the reality. That's the industry. That's where the industry really should look.
You're definitely right. And so one thing I always mention to folks, I'm like, look, if you want to really see what your battery manufacturer is going to warranty, look at their warranty letter and look at their cycle life, sure, but also look at their energy throughput. Energy throughput is essentially the amount of power that is expected to be stored and delivered throughout the battery's life. Okay, it's usually a megawatt hour number. So for example, the Evault Max has 88.8 megawatt hours of energy throughput, meaning that throughout its life, it's going to deliver 88.8 megawatt hours. There are some assumptions that are being made there. Okay, so it's not just like you just get it because it's there. There are some assumptions. You got to use this thing the right way, just like your car. You know, if you're putting diesel in your car, you're not going to get 200,000 miles. You know, you got to use gas. Do not use diesel in your car, by the way. Just a disclaimer. What this chart is saying is that depending on your depth of discharge, which is a percentage of how much of your capacity of your battery is using, it's going to influence how many cycles, aka how much energy throughput, megawatt hours, you can expect to be delivered. We have an 80% depth of discharge, right? So 80% of that battery is what I'll call usable capacity. Evault Max is 18.5 kilowatt hours. 18.5 times 0.8 is 15, maybe 14.8 kilowatt hours of usable capacity. You can use more of your battery, i.e. 90% depth of discharge. If you look at that red line, that's 100%. But if you look at that red line, somewhere in between that green and that red is where 90% is going to lay, right? And you'll see that you're getting more usable power, but the trade-off, because there's no such thing as a free lunch, the trade-off is that you're going to get less life cycles. The same thinking applies in that other direction. You use less power, 50% depth of discharge, that blue line, okay? You're going to get more cycles out of your battery. What does that mean? It means more energy throughput. It means more power, which means more longevity. The next slide, you'll see cycle life and relates to depth of discharge at 0.5 C.
We're not going there yet. Hold on. I just want to talk about something really quick, Alex.
Okay.
All right. So here's the thing. Here's the interesting consideration from the design perspective. All right. From the design perspective, when we look at your applications, but let's just say there's a brand new, installation. Let's say, for example, it's off grid, and you're going to do a load evaluation and come up with a hypothetical energy consumption, right? We're usually going to design around an 80% depth of discharge target, because we know that during certain points in the use of the system, let's say certain times of the year, you're likely going to use less energy, and as a maximum, we're going to use 80%, right? So in the event you get to a 20% state of charge, which is 80% depth of discharge, I know that was all over the place, but you're going to have maybe a backup generator, or if it's grid interactive, you're going to have grid pass-through come in. But ideally, rarely are you going to hit that 20% remaining capacity, right? In the event we have a backup generator, in the event we have the grid, ideally we'll target the usable energy needed from the battery bank as a factor of your consistent draw and your consistent load, and then we'll target that, right? So, but the point and takeaway of this is, just because you target that 80% depth of discharge, rarely is a system going to be hitting that 80% depth of discharge, if designed correctly, every single day, unless that is your specific design principle. So that's why throughput is kind of an important consideration, I think more important, because throughput allows you to quantify to some degree your cycles, because it's essentially that equation. Like, it's an equation, you can look it up. In fact, Fortress has a really good write-up on the equation of throughput energy, and it's a factor of efficiency and depth of discharge at specific state of charges and such. Like, you combine it all together and you get an energy throughput value. And that's because the depth of discharge is a variable, it's never consistent. You can always expect more cycles. Well, you should, if designed correctly, expect more cycles from the battery than what the manufacturer says in a given situation, unless you're abusing the battery. In that case is where you're, maybe 90% discharge or 100% discharge regularly, and you certainly are not going to get the life off the battery, right? So anyways, let's transition to the voltage.
Go to that next slide, because the next slide is, from a designer's point of view. If you're James, you're thinking of, you have all these different things. A lot of us, we just think, they just work their magic and it's easy to design a battery, but very rarely is it as kind of transparent as it should be, right? Because there's depth of discharge, there's temperature, internal and external, there's C rating, there's all these different things. As a designer, we just want to help manage expectations, right? We don't want to sell you a system that, isn't going to do what you want it to do, right? And so one of those things that influences batteries is the temperature, right? How hot or how cold is that battery? I mean, we all, I think, have seen cold temperatures, not good for batteries, right? So some of our solutions have some active heating, so on and so forth. And you see, as you get into hotter temperatures, you have pretty consistent in terms of your capacity. But the problem with higher temperatures is that, remember, there's very fragile electronics in your battery. So you want to make sure as you're designing your system, whether you're reaching out to Northern Arizona or if you're doing this by yourself, think about these sorts of things. Where is the battery being installed? How am I going to be using this? And I'll touch on C rate quickly. Essentially, C rate is how quickly are you going to discharge this battery? There's other charts and data out there. I do not have one here on this slide deck, but higher the C rate, you get higher temperatures, right? Higher temperatures means that the possibility that the battery is going to have shorter life is very possible, right? So although it is good to get very fast discharge, right? Electric vehicles are a pretty cool application. They're using a very fast discharge, but that's a different chemistry. So as a designer, you want to make sure that, hey, we have this impact on temperature. We want to design a system that is, let's say, these are all Celsius, but like this green line, like 50 degrees Fahrenheit to like this, not this red line, that red line's way too hot. Like this like blue line, or maybe even this yellow line at 113 degrees Fahrenheit, right? So temperature plays a big part in how long you can expect your battery to last. And then in addition to that, you have this idea of sear rate, which again, the faster you discharge or charge your battery, the higher the temperature becomes, which means that the possibility for shorter lifespan or energy throughput is very possible, right? Do your research. This is all public information found online, whether it's Fortress Power. NAZ has a fantastic training platform. Sorry to steal your thunder, but make sure that you do your research before. You know, it's just going to help you make a better decision, and heck, you might even learn something along the way.
So I just want to pop back into the Evault Max, just because it's from a design perspective, it's a really important battery for us. And like, just to say, like, each of these batteries is 18.5 kilowatt hours. It's a big platform to work with. We usually use them essentially as 15 kilowatt hour usable blocks. All right. I don't know. The analogy of a Lego castle is kind of what I like to use when I'm talking to customers about how these things are scalable. And we will essentially use these batteries in these 15 kilowatt hour usable, that's to that 80% depth of discharge. Like if you take 18.5 kilowatt hours and 80% depth of discharge, you'll get 15 kilowatt hours. It's a really easy number to work with, right? 15 is pretty nice. And then, we will essentially scale these things up to 20 batteries in certain cases and, get 370 kilowatt hour systems put together if we need to, right? So this is just an example of a relatively large system with, lots of Sol-Arks and lots of batteries, lots of solar, essentially to be a completely redundant backup solution to the grid, long-term, like self-sustaining, super important. The other aspect of the Evault Max battery that's really ideal for us is that these batteries are easy to retrofit into existing systems. I mean, they're compatible with Schneider, Sunny Islands, Outback. You can use them with Morningstar charge controllers and such, Focus inverters. I mean, even Magnum. Like, these batteries are agnostic with respect to the inverter that they work with, but they certainly work really well with Sol-Ark and Victron because, personally, from my perspective, they do work. The closed loop communications works really well with these two platforms, okay? So, and the scalability of those two platforms is kind of important. I will often use in projects out of the United States, Victron to do really large, high power, even 3-phase systems so that we're able to do, unique, systems, both AC coupled and DC coupled with Victron. With Sol-Ark here in the United States, with the UL 9540 listings and 9540A listing for the Evault Max battery and the interactive listings with Sol-Ark, it works really well in closed loop with those projects. So when we're doing very large projects with these, platforms, the Evault is like the design consideration for that, plus retrofittable into any of these existing systems with Schneider and SMA and such. The closed loop aspect, Alex, confirm you got closed loop with Schneider and SMA as well, right?
Sorry, we have with Schneider SMA. We're finalizing that. We should be on their AVL very shortly, but we've done some internal testing and it worked, but we're just waiting on SMA to finalize to get on their AVL. But we do have the protocols there.
Perfect. When it comes to like busing these things together, there's a lot of different ways to do this, but Alex, I'll kind of let you take this.
Yeah, and so busing is a fancy word for putting all these things together. Yeah, so when we talk to busing, there's many different ways that you can do it, as James alluded to, right? So on the side of each of the Evault Max, there's a 2-inch knockout. Actually, it might be like 1.75 inches. I'll say 2 inches for simplicity.
No, if
There's
it's a 2-inch conduit, yeah.
So it's a 2-inch knockout. You pop open the knockout. You could do a 2-aught or 4-aught battery cable, and then where that cable lands, it's going to land on the bus. The bus, again, is just a fancy word for ganging all these up together. There's different companies out there that make busing solutions like Blue Sea, Reliance, and it looks like to the right of that Evault Max, it looks like that kind of solution. So it's where you're landing physical connections of battery cable conduit from the battery terminals, lands on the bus, you screw it in, and then it's going to treat, again, that bus is going to take all the amperage from that battery, handle it, and then deliver it back to, let's say, the PV and the inverter, and then back to the home load. There are many ways that you can do busing, right? We always recommend that if you have a project with 2 or more Evault Maxes, you do a bus bar, right? A one-to-one with, you know, a Sol-Ark or an NV or whatever, you can just go right from the hybrid inverter right down to the battery. No fuss, no muss. As you get into larger systems, you want a way that you can balance the power coming from all these batteries onto a bus bar, which is like a big piece of metal, so that way all the amperage can go into the bus bar and then goes up to where the inverter is, and then the inverter can deliver that power to wherever it needs to go, back to the utility, to the home load, wherever, you know. So there's a lot of resources on our website, fortresspower.com. Go to resources. We have all sorts of different articles and tips and tricks on different busing, because a lot of it's dependent on what size system you're building, right? Large battery systems need large bus bars. Smaller systems don't need as large bus bars. So please go ahead.
Yeah, no, if you just need help sizing your bus bars and, you know, to handle the inverter loads and the battery loads, you know, certainly our team will be able to help you with putting that together. That's by default if you do need, you know, any of that help. So yeah, again, just to summarize this, I mean, if you need to increase your capacity with the, you know, eVault Max batteries, you just parallel them together, right? It's a 51.2 volt battery. You know, most of your systems are essentially going to be nominal 48 volt, and so you're going to parallel them together. You never would series them. We don't ever recommend seriesing any lithium battery for that matter. And so, you know, using bus bars to essentially parallel them is, you know, the best practice. I do want to talk about a couple of applications, case study kind of situations. Like right now, as we speak, I have a project that is kind of unique. So this is the Star School. This is essentially it was the first totally off-grid public charter school in the United States. It was founded in 2001, and as we speak, it's being completely retrofit with Fortress Evault Max batteries, and it's being completely rewired with the Sol-Ark inverters, you know, for a 3-phase 208 configuration. So this is, you know, an amazing project. We'll probably do a feature on it here, you know, shortly, like on our YouTube channel and such. A couple others. This is a scenario where, you know, we used Victron inverters and eVault Max batteries. Like there's not a lot of batteries that can provide the power that you need to deliver 60 kilowatts of inverter power in a closed loop communications kind of system. And so this is a massive, you know, 3-phase system that's running essentially a shop. It's going to have a huge amount of solar associated with it. It's just a beast of a system. And here's the important takeaway here is, you know, majority of the time that like in a shop or an off-grid, you know, potentially commercial operation, you know, the loads are running throughout the day. And so, you know, the battery capacity isn't super important per se. And so being able to have a battery that can deliver high amounts of power and support that inverter system is super important, because I mean, to some degree, the solar energy is going to be feeding the loads primarily, but the batteries are able to offset that demand, that peak demand that the inverters are going to be drawing in this off-grid situation. So it's super important design considerations, right? So like these are just some examples of some of the fun projects that we get to work on. If you want to learn more, I'm going to kind of turn this over to Heather here real quick.
Thanks, James. We do have a learning center. If you go down to the footer of our website and click on Learning Center, There's actually a search feature there too, so you can look for specific articles, but we have buying guides, articles, videos, and of course we have our YouTube channel. We are doing videos every month, deep dives into different products, different things to look for. So we're just trying to get a lot of information in your hands to help you make good choices. And then of course we always have our sales and engineering team.
And last but not least, Therese, to talk about the partner program and like a special project we worked on.
Yeah, so I am Therese. We have a great wholesale program here for all you installers. You can apply for that through our website. There's a partner program link on the website. If you are already a member, we are happy to have you. Go back a slide there, James. Sorry, I was just getting into that. So this was a project that we did with a native-owned installer who was working for the Navajo Tribal Utility Authority to install over 200 systems in residential settings in the types of houses you see right there on the Navajo Reservation. This was in 2020, so this was CARES Act funding. And we used Outback inverters in that case with Fortress Evault, and it has been tremendously successful. We haven't had any issues with any of the equipment that we know of. Maybe one Outback inverter was warranted, but the batteries have been absolutely rock solid. And in this case, we did provide a design with a heater in the small building that they built for the system, and that has kept those batteries going for the last, almost 3 years now. So we were very happy to be involved with that and looking forward to lots more projects like that. So yeah, my contact information is on that partner program link on the website. Reach out to me if you have any questions about the program. We are stocking huge inventories. We're shipping very quickly, and you get personal attention to every single order through that partner program, as well as, of course, great pricing. So hit us up.
Cool. Thank you guys for joining the webinar. James, Therese, thank you for your time. Heather, thank you also for joining us here and helping organize this webinar. For all my folks out there watching, thank you for your time. I know we're a little over time, but a couple just final notes. If you have questions, contact Fortress Power or the Northern Arizona team. I have not only my direct information there, but also James has been gracious enough to put his information there as well. We will have the recording of this webinar, the PowerPoint slides, all sent to you guys after the fact. So thank you again for joining us, and NAWS team, thank you again for co-hosting with me. I had a great time today. Great time.
Thank you, Alex.
Thank you, Alex.
Thanks, guys.